Evaluating indefinite integrals, the wild ride of antiderivatives. Hey there, math adventurers. Today, we're diving headfirst into the thrilling world of indefinite integrals. Buckle up, because this is going to be a wild ride. What's an indefinite integral, anyway? Imagine you're on a roller coaster. You start at the top of the hill, and as you zoom down, you're experiencing a change in your position. An indefinite integral is like the reverse of that roller coaster ride. Instead of knowing the change and finding the position, you're given the position and need to find the change. Step 1. Identify the function. First things first, you need to identify the function you're integrating. Let's say we have a function fx. For example, fx is equal to 3x squared plus 2x plus 1.
Step 2. Find the antiderivative. Now, you need to find the antiderivative of fx. Think of it as finding the original function before it was differentiated. The antiderivative of 3x squared is x cubic, the antiderivative of 2x is x squared, and the antiderivative of 1 is x, so the antiderivative of 3x squared plus 2x plus 1 is x cubic plus x squared plus x.
Step 3. Add the constant of integration. Remember, when you differentiate a constant, you get 0. So, when you integrate, you need to add a constant c to account for all possible antiderivatives. This constant is called the constant of integration. So the indefinite integral of 3x squared plus 2x plus 1 is x cubic plus x squared plus x plus c.
Step 4. Verify your answer. To make sure you didn't mess up, you can differentiate your answer and see if you get back to the original function. If you differentiate x cubic plus x squared plus x plus c, you should get 3x squared plus 2x plus 1. Example time. Let's do an example together. Say we have the function fx equals 5x power 4 minus 3x squared plus 2. Identify the function f of x is equal to 5x power 4 minus 3x squared plus 2. Find the antiderivative. The antiderivative of 5x raised to power 4 is x raised to power 5. The antiderivative of negative 3x squared is x cubic. The antiderivative of 2 is 2x.
Tips and tricks. Practice makes perfect. The more you practice, the better you'll get. Try integrating different functions to get the hang of it. Use the power rule. Remember, the power rule for integration is the integral x power n dx equals to x power n plus 1 over n plus 1 plus c, where n is not equal to negative 1. Don't forget the constant. Always add that constant of integration c.
Sure, let's dive into 2 real-life examples, where indefinite integrals play a crucial role. These examples will help illustrate how integrals are used in practical scenarios beyond the classroom. Example 1. Calculating distance from velocity. Imagine you're driving a car, and you have a velocity function vt. That describes how your speed changes over time. The velocity function might look something like vt equals 3t plus 2, where t is time in seconds and vt is velocity in meters per second.
To find the distance traveled over a certain time interval, you need to integrate the velocity function. The distance st, traveled from time t, equals 0 to time t, is given by the indefinite integral of the velocity function. St is equal to integral of 3t plus 2 dt. Let's solve this integral. Identify the function. Vt equals 3t plus 2.
Find the antiderivative. The antiderivative of 3t is 3 over 2, t squared. The antiderivative of 2 is 2t. Add the constant of integration, st, equals 3 over 2, t squared, plus 2t plus c. To find the distance traveled from t equals 0 to t equals 5 seconds, you evaluate the definite integral.
So, the car travels 47.5 meters in 5 seconds. Example 2. Calculating total cost from a marginal cost function. Suppose you run a factory and you have a marginal cost function C-X that describes the cost of producing one additional unit of a product. The marginal cost function might be C-X equals 2x plus 5, where x is the number of units produced. To find the total cost of producing x units, you need to integrate the marginal cost function. The total cost Cx is given by the indefinite integral of the marginal cost function. Cx equals integral 2x plus 5 dx.
Let's solve this integral. Identify the function. C-x equals 2x plus 5. Find the antiderivative. The antiderivative of 2x is x squared. The antiderivative of 5 is 5x. Add the constant of integration. Cx equals x squared plus 5x plus c.
To find the total cost of producing 10 units, you evaluate the definite integral. So, the total cost of producing 10 units is $150. These examples show how indefinite integrals are used in real-life situations to calculate distance from velocity and total cost from marginal cost. Integrals are powerful tools that help us understand and solve a wide range of problems in physics, economics, and many other fields.
Conclusion, and that's a wrap, folks. Evaluating indefinite integrals might seem daunting at first, but with a little practice, you'll be a pro in no time. So, grab your calculators and get integrating. Stay tuned for more math adventures, and remember, math is fun, and integrals are just another roller coaster ride.